Hi, my name is Darshan and I'm an online tutor of math and physics. This is FRQ number 2 of AP Calculus BC 2023 exam. It's based on particle motion in a plane, so x and y both are changing over here. It's not a straight line. Let's read the question. For 0 to pi time, a particle is moving along the curve shown, so its position at particular time, x and y positions are given by this particular graph, where x is not explicitly given and yt is 2 sine t. All right, okay, yt is 2 sine t, so that makes perfect sense. X is not defined in terms of t, but y is defined in terms of t. That's what they want to say. And it is known that dx over dt is e raised to cos t. So the change of the value of x with respect to time is given. X is not given, or the rate of change of x is given. And at t equal to 0, the particle is at the position 1, 0. So its x coordinate is 1 and the y coordinate is 0, which is pretty evident from the graph as well. First question is, find the acceleration vector of the particle at time t equal to 1 and show the step of your calculation. All right, okay, we know that the acceleration, and remember, we need to find the acceleration vector. So there will be an acceleration in the x direction and in the y direction as well. For the acceleration in the x direction a sub x, it is going to be x double prime t, because that's the double derivative of the position, right? The single derivative is the velocity and the double derivative is the acceleration. So it's double derivative. Fortunately, we are already given the first derivative of x, which is e raised to cos t. So our aim is to find the derivative of e raised to cos t once again. So we are looking for d over dt of e raised to cos t, and that too we need that value at t equal to 1, right? So we need this at t equal to 1. We won't make the effort of doing this manually because the calculator is allowed. So we get some value which we'll find, and the value of ay will be given as the double derivative of the y function, of course. So it will be d square over dt square of the y function, and the y function is already given to us as 2 sine t. So this comes over here as 2 sine t. And once again, we need this value at t equal to 1. So all we need to do is go in the calculator section and find this up. Give me about 1 minute to find these things. Feel free to fast forward. I'm going to take a screenshot anyway and put it on the board so that you can also see what I've done. So x is e raised to cos t, and the value of dx over dt, that's what we are looking for. So let's call it fx, and this is f prime 1, right? F prime 1, that's what we are looking for. So this is x, so we got the value of f prime 1. And likewise, so what is x? I will just tell you just in a minute. This is 2 sine, and we are looking for g double prime of 1, which is also something which we have. So this is my calculation. Let me just take a screenshot and pull that right in front of the board so that you can also see. Okay, so this is what I did. We needed all right, I think this is a good position. Yeah. Okay, so what we needed was the first derivative of e raised to cos t at t equal to 1. So this is e raised to cos. It doesn't matter whether we have x or t, the variable is irrelevant. We have to find the first derivative. So I did f prime of 1. So first derivative at 1, which is this is ax. And then I need I wanted to take the second derivative of 2 sine t, so it's 2 sine, and at 1, so it will be g double prime, so second derivative at 1, so I got this as ay. So the acceleration is going to be negative 1.44 and negative 1.68. So I'm going to write that the acceleration vector in the vector form is going to be negative 1.44 comma negative 1.68, either like this, or if you're a big fan of I hat and j hat, you can also write like that. So we can also say that, or the acceleration is negative 1.44 I hat minus negative 1.68 j hat. Both are acceptable answers. So there is no right or wrong answer. Both are correct. But make sure we write that in vector form because they are clearly asking the vector form over here. All right. All right. This is the first question of first part of question number 2. The second part is asking that for t equal to 0 to pi, find the first time t at which the speed of the particle is 1.5. Let's ask ourselves, what is the formula for the speed? The speed of the particle is the absolute value of the velocity function and is given by root of, what is the root of speed in the velocity in the x direction square plus velocity in the y direction square? A very straightforward formula. What is the value of Vx? Vx is the first derivative of the position function in x. So it will be x prime t whole square plus y prime, likewise y prime t whole square. All right. Remember that we are already given the value of x prime t, right? X prime t is right here. It's e raised to cos t. So I'm going to plug that in over here, e raised to cos t whole square, and then I need the value of y prime t. I'm already given y, which is 2 sine t. So y is given 2 sine t. Y prime is very easy to find because that is going to be just 2 cos t. So this is how we write 2 cos t whole square over here, and then we take the square root. And remember that we need to solve this such that the speed should be 1.5. So the left side should be 1.5, and we need the first instant when this happens, right? Obviously there will be various values of t when this happens, but they are looking at when this happens for the first time. So I'm going to go ahead and use, of course, the graphical calculator. It's we cannot do it manually, of course. So that's going to be root of e raised to cos x, because I'm using the variable of x, plus 2 cos x whole square. Make sure your calculator is in radian mode, because if it's in degree mode, you're going to get an entirely incorrect answer. Please make sure you do that. I have ensured that it is in degree mode, my calculator, so I think I'm gonna get the correct answer. All right, so the first time which I'm getting from here is, okay, I'm getting 1.254, and I'm gonna now pull that up so that you can also see. Okay, I'll explain what I did. Okay, I will explain like this, then I will move around. Okay, so what I did is I basically graphed the function which we had. Okay, I think, yeah. So this is the function which we had, e raised to cos x whole square plus 2 cos x whole square, and I just brought this 1.5 over on the other side, so it became minus 1.5. And basically we are looking for the points where it intersects the x-axis, because you know, that will be its roots, and the first point where it intersects the x-axis is 1.254. And that is the reason why I got 1.254. If you're using the TI calculators, then obviously there will be a different way in which you get the answer, but it doesn't matter, you're going to get the same answer. So this is 1.254. I'm going to move this down. So 1.254 is my answer, which I'm going to write over here. 1.254 is the first instant at which the first time at which this the speed of the particle becomes 1.5 units. I hope this makes sense. Let's move ahead to the next question. Find the slope of the line tangent to the path of the particle at t equal to 1. That's an interesting question. Find the x coordinate of the position of the particle at time t equal to 1. Should have worked. That leads to your answers. Slope of the line tangent to the path is nothing but rise over run, right? So the slope is nothing but the rise, which is y, dy, over the run, which is dx. But we don't know the relation of y with respect to x, which is absolutely fine, because we are going to manipulate this now to write. Can we write it as dy over dt over dx over dt? Absolutely, because I just divided the numerator and denominator by dt, right? So that's going to look like dy over dt over dx over dt. This is what we had, and the value of y, the function y is nothing but 2 sine t. So we know that the derivative of 2 sine t is just 2 cos t. So dy over dt is going to be 2 cos t. So I'm going to put that over here. This will be 2 cos t. And the dx over dt is already given to us. That is e raised to cos t in the question. So I'm going to put e raised to cos t over here. And this we need to find at t equal to 1, of course. Remember, cos 1 we do not know. We got to find the value of cos of 1 by plugging this into the calculator. So let me plug this in. 2 cos 1. Once again, please make sure that your calculator is in radian modes, otherwise you're going to get an incorrect answer. So I'm getting 0.62. Okay, I'm going to pull this up in front of you. Okay, this is what I'm getting. 0.6295. So this is the slope, which is 0.6295. Are they asking something? Find the slope of the tangent to the line. I think that's it. They're asking the x coordinate. The next part is they're asking what is the x coordinate of the position of the particle at t equal to 1. So they're asking the value of x, right? Okay, that's interesting. Let me try to make some space over here so that I can do the other part. All right, that's good. Okay, so if you want to find the value of the x coordinate, and remember that we are not given the function of x, we are only given the derivative. And what is the derivative of x, by the way? X prime is e raised to cos t. So that's fine. We can just take the antiderivative now on both the sides from 0 to 1, because we need to find the value of x as 1. And one very important thing is given to us, that excuse me, at t equal to 0, the x coordinate of the particle is 1. So its initial condition is given to us, which we are going to use in the antiderivative as a definite integral to find the value of the value of x at t equal to 1. So I'm going to put the antiderivative integral sign on both the sides, and that too from 0 to 1 of x prime dt, and this is going to be e raised to cos t dt once again from 0 to 1. Yeah, if we integrate x prime, I'm just going to get x, and if I put the upper limit, that's going to be the x at 1 minus the x at 0. And this guy, of course, I'm going to go back and solve this using a calculator. So e raised to cos x, e raised to cos x dx, integral within the limits of 0 to 1. Okay, this is what I am getting. I'll just pull that in front of you. This is what I am getting over here. I'll just put it perhaps, we shrink the size over here. This is what I'm getting as 2.34. From 0 to 1. So this is 2.34, and the value of x0, like I already said, is 1. So the value of x1 minus 1 is 2.34, and all we have to do is just add 1 both the sides. So if you add 1 both the sides, obviously you're going to end up with 3.34 as the value of x of 1. Do they need units? I don't think so, but if they have given the units anywhere, we can. I don't see units anywhere. The miles, meters. Nope. No units are given. So x1 is 3.34. We're going to leave it like this. That's the final answer for both the subparts given in part C. All right, the last question is find the total distance traveled by the particle from 0 to pi. Remember, this is a direct formula. We should know this formula, that the value of the distance, the expression for the distance in the case of a plane curve, not a straight line, plane curve, is nothing but the integration of the speed from whatever points, between whichever points we need. So that's going to be 0 to pi, and remember we already have the expression for speed. We are not going to do it again. We're just going to borrow it from here, right? This is the expression for the speed, so I'm going to borrow this and paste it right here. This is what I'm looking for, and this is what I need to integrate from 0 to pi. Right, that's going to be my answer. So let me just go back once again to my calculator and get this value. I have a square root. That's a pretty big expression. It's going to take at least 1 minute for me to plug that in. E raised to cos x. Once again, please make sure that your calculator is in radian mode. We don't want to make that mistake, make that small mistake and get our complete answer incorrect. And the integral limits are from 0 to pi. 0 to pi, right? So this value comes out as, oops, I missed something, squared. All right. So the value which I'm getting here is 6.03. That's what I'm getting. I'm going to pull my work in front of you so that you can also see this is what I did. Just plug that into the calculator. So I'm getting 6.03. Once again, I don't think so we have units, so this is my unitless answer. Whatever units is of the distance, that's going to be my answer. All right, I hope this makes sense. This was the second question. If you have your answers different of any of the question, please comment and we can discuss. Maybe I have messed up somewhere, or maybe you have, so I can help you in figuring out where you what correction you have to make to get the correct answer. And if the video is helpful, please subscribe to my channel. Bye bye.